Every part will be visually inspected for cracks or damage. After a visual once-over, the block and heads need to be checked for hard-to-see hairline fractures or cracks.
Any parts made of cast iron can be magnafluxed. For this process, an electromagnet is stuck on the part and then it's sprayed with a special powder that will stick to any cracks and make them very visible. Magnaflux doesn't work on aluminum parts. They need to go through a dye process to make cracks visible. Once the machine shop knows if the parts are still good and not cracked, they can measure the tolerances to see what machining is going to be necessary. If the visual inspection showed that there was obvious scratches or damage to the cylinder walls in the block, then the pistons would be considered junk and the block would need to be bored out. If the visual and the magnaflux of the block was okay, a dial bore gauge would be used to check the cylinders to see if they were out of round or if there was a taper from the bottom to the top of the cylinder. The dial bore gauge will tell the machinist if the cylinder has to be bored to straighten it out or if a hone is going to be all that's needed to clean up the cylinder walls. In either case, the pistons have to be measured. If it's a bore and hone job, new pistons are going to have to be used. The new pistons don't have to be on hand for the boring process, but they do have to be physically measured to determine the size of the final hone.
Piston size is a constant and cannot be machined. With the piston inverted, the skirt is measured here just above the pin bore. This will determine if a used piston can be reinstalled in a block with just a hone job. In the case of a new set of pistons, the diameter found with the micrometer will tell the machinist what dimension to hone the block to. This way the pistons will have the proper clearance in the cylinders. If a piston is measured and found to be worn too far, it is considered a collapsed piston and cannot be reused.
Both cast iron and aluminum heads will get a close visual inspection. Some machine shops even have a vacuum fixture that can test how well the valve seats are sealing. The valve guide, which is the hole in the head where the valve slides, is checked for excessive play, and if wear is found, the valve stem might be checked with a micrometer to make sure the valve can be reused. For the valve train, the camshaft and lifters should be examined. Any signs of wear will indicate that all the lifters and the cam will need to be replaced. As we said before, it's pretty much a standard procedure to replace the cam and lifters for almost every rebuild. The valves and springs will get inspected a little bit later on. Any push rods that don't roll smoothly on a piece of glass should be replaced, as well as any keepers, retainers, or rocker arms that have signs of damage. Remember to keep everything in order if you're planning on reusing the same parts.
Back to the short block, the crankshaft is also inspected and measured. If there are serious scratches or gouges in any of the journals, they will need to be ground undersized, and oversized bearings will be used later when we reassemble. Bearing manufacturers usually limit available sizes to standard 10, 20, and 30 thousandths of an inch oversized for cranks that have to be cut. This crank was cut 10 thousandths under on the main journal and 20 on the rod journals. Now it's getting the final polish to make the journals as smooth as glass. Sometimes the final polish is all that's necessary to return an old crankshaft to a usable status. The big and small ends of the connecting rods will be inspected too, and the rod bodies will be checked to make sure they're not bent or twisted.
After all the inspections and measurements, your machine shop